today we are going to start by trying to prove triangles congruent to each other and just remind you of the four congruent statements that we have. We have side, 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 and side, side, side is when you would have congruent sides equal to one another. So these sides might be congruent, these sides would be congruent, and these three sides. So we are just trying to prove, and so if I can show that all three sides of these triangles are congruent to one another, then these two triangles are congruent by side, side, side. To remind you of side, angle, side, we would have to have, the way this is set up as a side, angle, side, we would have one side congruent to itself in one triangle, another side congruent, and then the angle in between would have to be congruent to one another. Now this works for side, angle, side, but this is not the only setup for this one. I could have done it, I could have erased these two sides here and say, what if these sides were the ones that were congruent to one another? Then we would have angle A and angle X, because it is side, side, angle, side. On top of this, we have angle, side, angle, and in this case, the side is between the angles, so it doesn't really matter which angles I would choose. Maybe angle A and angle X would be congruent, and maybe angle C would be congruent to angle Z, and therefore the side in between of AC and XZ would have to be congruent for this to be proven by angle, side, angle. And then the last one is the final congruence that we have, and that would be angle, angle, side. And so what we would need is two angles two angles congruent to each other, like this. Maybe I have angle A and angle X, and angle B and angle Y congruent, and then any side that is not between them, maybe this side down here, with BC and X and YZ, or even possibly I could have these two sides over here, but it just cannot be the side between, like it cannot be the side between the two angles, therefore it would end up being angle, side, angle if the side was between them. So this setup is what we're looking at is angle, angle, side. Alright, so let's put this to work then and see what we can do. Alright, so we've got these three problems and we're trying to figure out how these guys are congruent to each other or if there is enough information. So let's start by labeling these guys. Angle B and angle Y are congruent, so angle B and angle Y are congruent. Angle A here is congruent to angle Z. And finally, BC is congruent to YX. Well, if you notice, I have two angles in the side not between it, so this one would be, these two triangles would be congruent by angle, angle, side. In the next one here, we have angle C is congruent to angle X. Angle A here is congruent to angle Z, and we would have CA is congruent to XZ. And in this case, how would these triangles be congruent? Well, they would be congruent by angle, side, angle. And the last one here, if we have AC is congruent to ZX, AC is congruent to ZX, angle B up here is congruent to angle Y, and then BC is congruent to YX, which would be this one. Now you'll notice that I have an angle and two sides, and angle and two sides cannot be congruent to one another. So we end up, this one is not enough information to prove that these guys are congruent, because angle, side, side is not one of our options for proving triangles congruent. Let's try another example here. Alright, so this one is asking that they're trying to prove the triangles congruent by the given information. So this one wants it by side, angle, side. Well, what additional information would we need to prove that these triangles were congruent by side, angle, side? Well, right now, looking at this, we have a side congruent and an angle congruent, so it looks like we would need a third side. And the angle needs to be between those two sides, so which sides would we be looking for? Well, we'd be looking for segment DA is congruent to segment TO. In the second example here, we're trying to prove by angle, side, angle. Well, it looks like we have the exact same information we had before. We have a pair of angles and we have a pair of sides, but we need an angle. Now, where does this angle need to be? It needs to be along the side the side would be included between the two angles because it is angle side angle. So the angle that we would be looking for would have to be, looks like, well, what would it be? It would be angle N would have to be congruent to angle M to prove it by angle side angle. That would be these angles at the top up here. Oops, we mark them differently. All right, and down here, if we're trying to prove it by angle, angle, side, well, angle, angle, side, we have an angle and a side so far. And so in this case, the other angle that we're looking for does not have to be on the end. So because if it's N and M like we had in the previous example, then it would be angle, side, angle. But in this case, we would need angle A and angle T and angle O to be congruent so that we would end up with angle, angle, side. All right, so these are the setups of the different types of triangles and the different ways we can go proving these things. And so then we have one more type that we are going to work on here. And so in this one, they have tick marks and things like that on the drawing, and we're going to use our four congruent statements of side, 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 angle, angle, and angle, angle, side to prove that these triangles are congruent. If we cannot get enough information, then we're going to call it not possible. But we do have a reflexive side and vertical angles that we have to be aware of. Well, in this triangle, I notice I have a side, two sides congruent in one triangle on this side and one triangle on that side. Well, if I have a 90-degree angle in a linear pair, that makes this guy 90 degrees as well, so it looks like I've got a pair of angles. And finally, I do have a reflexive side right here, so it looks like I can prove these two triangles congruent by side, angle, side, because I have a side, an angle, and a side, where the angle is between the two sides. Now remember that we're proving by these things up here, so if we're looking at example 2, you'll notice in all of these up here, I need at least one side. Well, down here, I only have 3 pairs of angles congruent to one another. Even though the drawings look like they were congruent to each other, we need a side according to our 4 congruence things up here, our 4 congruence theorems up here. So it looks like we have to do it by, this one cannot be done. This is angle, angle, angle. And angle, angle, angle is not one of our congruence postulates. So we can call this one not possible. And finally, we have the last one down here. We've got 2 pairs of sides. So with 2 pairs of sides, angle, angle, side is going to be out, and angle, side, angle is out. So I'm down to these 2 situations. I've got side, 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 and side, angle, side. Well, I don't know anything about WV and XY. There is no information given about those. But I do know things about when 2 lines cross, that these guys are vertical angles, and that vertical angles are congruent. So when vertical angles are congruent, then I can say I've got enough information to prove that this top triangle, that X, Z, Y, is congruent to VZW by side, angle, side. So we will do a little bit more practice of this in class, and we can talk more about this if you have any questions. Thank you.